the total internal reflections. This concept will explain the reason for the phenomena of some remarkable observations in nature. The remarkable observations in nature. One such observation is the sparkling of diamond. Diamond is a very shining object. The brilliance is extraordinary. There is no other such material found in nature like diamond. The diamond, the refractive index of the diamond by experiment is found to be the value 2.45. Look at the value, is quite a high value. Refractive index is quite high, and comparatively very high with respect to the atmospheric air surrounding the diamond. The refractive index of air is 1. The refractive index of diamond is 2.5. Here, that is what Snell's law, when the ray of light is from diamond to atmospheric air, talking about sin I by sin R, and it is 1, that is atmospheric air, 1 divided by 2.45. So this ratio is lower value for diamond, for a pair of diamond and air. Lower the value of ratio, lower is the value of C. That is, in case of diamond, critical angle, C stands for critical angle, is very much low, a lower value. This lower value of critical angle will favor the internal reflections. Total internal reflection is very much favorable. Lower value of critical angle is very much favorable for total internal reflection. Before we go for in detail, let us look into the chemistry of diamond. What is diamond? Diamond is an elemental substance, a solid elemental substance. It is made of only carbon atoms, elemental substance. In the solid, each carbon is surrounded by 4 other carbon atoms in tetrahedral fashion and connected by chemical bonds known as covalent bond, the stronger bond. And the spatial orientation is symmetry, that is, they are equally directed in space all around the carbon atom. That is, angle between any two chemical bond always equal to 109.5 degree. That is a symmetry about the carbon and its geometrical structure. And each carbon has this kind of fashion. When you look at the many carbon atoms like this, about this carbon, the same geometry, carbon, 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 geometrical, tetrahedral geometrical arrangement of chemical bonds. And about the carbon connected with this to this bond is again connected to 4 other carbon atoms including this carbon. That is 4 carbon atoms. Again 4 carbon atoms. Again 4 carbon atoms. Look at the structure. It is similar all over. And entire, what is that? It is like a polymer molecule, no break. Polymer means a molecule containing, that is, billions of atoms connected by chemical bonds. That structure is called a single crystal, no break. Is a polymer molecule with a perfect structure like this. If all the atoms are only carbon in the solid and each carbon is in tetrahedral fraction, perfect tetrahedral fashion, each carbon is in tetrahedral fashion like this, every carbon, it is called as 100% diamond. 100%, what is that? Structural quality, no structural defect. If any few atoms in the diamond, the carbon here or somewhere, replaced by other atoms like nitrogen or boron and some other atoms as well, in traces, even in traces, that will impute the diamond. And this impure diamond is not of that optical property, loses its optical property. That is one way. Not only the presence of chemical impurity, there is also physical structure, that is crystal structure. Any defect in the crystal structure, that is this kind of orientation is different at any other points around the carbon, that is called crystal defect. That crystal defect also reduces the optical property of diamond. Not only chemical impurity, it requires perfectly crystalline material for a great brilliance of diamond. That diamond is called as 100% pure diamond. The diamond is available in nature as well as we make by synthetic preparation. That is, in nature, diamond is available under earth crust. It is created by the carbonaceous material. It is created by the carbonaceous material trapped under earth crust and subjected to what is that, a continuous chemical and physical process over a period of time, millions of years, by the action of very high temperature and very high pressure. That is, under earth crust, usually you find very high temperature and high pressure. Under this condition, the carbonaceous material undergoes a series of reactions and a series of changes in physical structure. Finally, it becomes a diamond like this. That is a natural diamond. We take out the diamond by mining. It is known as natural diamond. We can also prepare diamond in lab. That is synthetic method. There are a number of chemical methods are available now. In one such material, we are subjecting the graphite material, is carbonaceous material, into a very high temperature and high pressure, and carefully, that is converting, very slow process, slowly and carefully converting that graphite material into diamond. It takes utmost care and requires very slow process, very high temperature, high pressure. That is one stage. And there are many chemical methods available to make diamond like that. That is synthetic diamond. Both are similar. Whether you make diamond by synthetic process or we take it from the nature, the diamond is similar. Once you collect the diamond like this, it can be cut and polished into many phases or multiple phases like this. That is different phases, multiple phases of different geometry, triangular geometry, rectangular geometry, square geometry like this. It is possible to cut into diamond, which is hard substance, very hardest substance in the nature, but it can be cut into what is that? Multiple faces, as many faces as you can. This is one such cut diamond, cut and polish. Once you get a diamond like this, we have multiple faces. And this diamond, let us talk about this. The brilliance of diamond, reason for the brilliance of diamond. This is the one. I am taking the diamond like this. Since it is a transparent, highly transparent material, when a ray of light enter from the surrounding, from the atmospheric air into the diamond like this, when a ray of light making entry like this, it will never come out from the other side. Instead, it will undergo reflection like this. It is called internal reflection. Internal reflection bounces back in the same material. The reason, the angle of incident at this point is greater than the critical angle. I said critical angle is lower in this case. This will very much favorable. So usually every angle of incidence is almost what is greater than the angle of greater than critical angle. That is why internal reflection. After the reflection, the reflected ray at this point at the surface, again one more reflection. Again angle of incidence is greater than critical angle. Another reflection like this. Another reflection at this face. Another reflection at this face. And finally will come out from the face like this. At every internal reflection, the angle of incidence is greater than critical angle. But here, when it comes out, when the angle of incidence is less than critical angle. Why? In so many cases like this, there may be a chance of case like this. That is why, at some incidence, finally, the angle is less than critical angle, it will come out usually from the top of the face. You need to understand this concept clearly. So look at this. One ray of light making entry into the material and come out from here. But see that it will appear as many rays of light inside. It is because of multiple reflection. One ray into, see the countdown. Every reflected ray is another number of rays. 1, 2, 3, 4, 5, 6, sometimes 10. Like this. Why this? If this happens, this ray has some intensity. But inside, when you go no, because of many rays, it becomes many rays due to multiple reflections. Many rays. Here, intensity is multiplied. One ray of intensity becomes many rays of intensity. If 10 rays are there, 10 times the intensity increase. Intensity of light in the material increase by multiple reflection, but itself will never emit any light. It will take the same light and multiply it before it will come out. But you are standing in the atmospheric air outside the diamond and looking at the diamond. When you look at the diamond of this intensity, anything at higher intensity, very much higher intensity, it should appear as a sparkling material, a shining material, a brilliance material. That is the reason why it is the brilliance of diamond. It is because of total internal reflection. This intensity of or brilliance of light depends on purity, structure, and also the cutting. That is, how many spaces cut like this, undergo many multiple. Cutting also will increase the number of reflections. If you increase the number of reflections, there is an increase in brilliance. It all depends on what is the property of the diamond as well as cutting of diamond. This is the reason for the brilliance of diamond. That is one such case. And one more case, it is mirage. What is mirage? It is another optical illusion. Let us look into it. That is the surface of the earth. Now I am taking the earth covering only sand or asphalt, the tar road or asphalt. There is sand, desert area. And the surface of the earth, always the light rays coming outside towards the earth surface like this at all angles. That is outside and surface at all possible angles. We can like this, like this, like this. This is the rays. I am selecting the rays, sun rays in this direction for this experiment. And the rays now, the material is sand or asphalt. That is the quality. What is the nature of this material? It gets heated up quickly by the sun rays, hot sun rays. Gets heated up quickly, quick heating, and rises the temperature of the atmospheric air adjacent to the earth's surface. There is a layer adjacent to the surface. It temperature rises because of the sand and asphalt getting heated quickly up and rise the temperature. Temperature rises. The rise in temperature, that is, the air becomes hotter air. And what about the layer of atmospheric air above that? Relatively colder. So here there is a division or dividing or separating. During sunny days, the atmospheric air near the surface getting divided into two layers. The atmospheric air of hotter and a layer of colder. And as you know, the temperature variation here, higher temperature, lower temperature. This difference in temperature will make a difference in density. More temperature, less density. Less temperature, more density. We are finding density variation. This density in case of air is directly related to the optical activity, the optical density. Higher density, higher optical density. Lower density, lower optical density. But in this case, direct relationship. So this layer is called as rarer layer. This layer is called as denser layer. So itself differentiated into two. What is that? A pair of two media, a media of lower density, a media of higher density. Because of this variation at this boundary, the boundary between these two layers, this boundary, when the light ray coming here undergoes refraction, coming from higher density to lower density, refracted away from the normal. So going straight, we can deviate it like this. So undergoes refraction due to this variation during sunny days, especially in this area. And this will not, the temperature will never constant, it keep varying. As the temperature, what is that? As the sun rises, it keeps varying. Temperature increases and the refractive index varies. Increasing temperature decreases the refractive index. This is Snell's law for this refraction. Sin is angle of incidence is angle of refraction. This is N2 is the refractive index of the second medium, N1 is the refractive index of the first medium. There is higher value, lower value. In this case, this I and N1 almost constant because we are keeping this angling is constant. This I is constant and N1 is almost constant. And these two becomes variable. As temperature rises, this will decrease and this will increase. Look at that, inversely related. This will decrease, this will increase. So angle of refraction increases. The reason, then the bending of ray, what is the bending away from this? Keep bending like this. And finally it becomes what is the direction like this. Instead of refraction, it becomes reflection like this. When the reflection occurs, this angle of incidence is more than the critical angle. At this condition, the angle of incidence is more than the critical angle at this temperature, higher temperature. Single case. This ray of light, see that parallel to this, is in this direction. Angle of alignment. This is called as angle of incidence, angle of reflection becomes. And this angle, what is that? We have to see that this angle of radiations, there is alignment with respect to the surface of the earth. This is and this is the same surface of the earth, almost, because it's parallel. This angle and this angle are usually very much lower value, very much close to the earth's surface. The reason here, the critical value of this pair of medium is very high. The reason, the difference is less. Refractive index value is less. Difference. If the difference is less, critical value, critical angle is more. This angle is more, then this angle must be smaller value. So critical angle for this, usually it is in the angle that is 75 degree to 85 degree. This is around 15 degree to 20 degree. Nearly along the, very much near the earth surface. This ray, what is that? Ray of light, that is ray at the height of about what is that? 3 feet from the surface of the earth, about 3 feet, 4 feet or 5 feet like that. This at the height of the surface. And this is what is that? Reflected ray. What reflected ray? Reflecting what is coming from the outside. It is from the sky towards the surface and reflect like this. If a man stands here, looks along this line is a ray of light. His view is at this point. Is he observing this earth surface? No, because this is a light ray not coming from here, it is coming from the sky. So is what is that? Observing. What is the sky? Is the object. This is the image of the sky. He is observing the sky on the surface of the earth. The reason here backward, extending backward, that is the direction. That is the image of the virtual image of the sky at this portion. For him, this portion is visible as, what is that? Virtual image of the sky. This virtual image of the sky appears as a ocean of sea. There is appearance, and this appears as ocean of sea or pond of water. Appears as water is present over here. The sky appears as water is present over here. It is called as optical illusion or known as mirage. But it is not water, it is only sand actually, appearing as this. This is for visibility of the man. If a deer enters into the desert or wanders from the forest into the desert and feels thirsty, looks for water for drinking. If the deer stands here, looking along this line, it appears as water is present over here. Then deer will run from this point to this point and not finding water, but find only sea, what is that? Sand. You find very sand only at this point. Then what will you do? When they stand again and look again along the line, one more mirage at some other distance. then what will do? It will run from here to that mirage. That will be repeated. What is repeated? Deer is running from the point to the virtual object. Again, point to the virtual object. Keep running. This, what is that? Will make the deer to continue. What is that? Continuous running. There is a continuous running of deer, but in vain. That is, all efforts are futile. All efforts are futile, running from here to here to find water, but only find sand only. This continuous running makes the deer exhausted. In that sunny hot day, eventually die of exhaustion. That is what happening. It is all about the mirage, optical illusion. And the concept is internal reflection, total internal reflection. These are the observations you are finding. What is that you are looking at in nature is explained by the total internal reflection. The sparkling of diamond and the mirage. So with this, let us stop and continue with in the next session. Thank you very much.